Hey my wonderful students, Jogman's here with your third topic, projectiles, also called 2D motion. In this video today, you're going to really get to understand how to apply the ideas we learned in class to these projectile situations. This video is going to have you take good notes and, more importantly, do two problems in depth. So make sure you have your class notebook out with lots of room. Different colors will help you, but it's not required. So as your notebook's out, here's the deal. Quick review. Is gravity a pull in both the x and y directions? And the answer is, of course, no way. Gravity only pulls you down, so it has no pull left or right. So when something's in the air, gravity's only making it end up downwards. It will not affect how far forward or backward it goes. So in the air, the x velocity, or how fast it's going forward, remains the same. The only thing gravity is doing is changing how fast it's going up or down. So here are the 5 strategies we're going to do. I'm going to let you pause for a little bit, write them down, then please press play when you're ready to rock and roll. Okay, here we go. First thing you always do is separate stuff into x and y parts. Now, we've done this using trig with things at angles, and we'll do that in our next video together. But right now, this is more of like looking at words and figuring out what goes in x, what goes in y. Number 2, we know gravity only pulls you downward, so that acceleration of negative 9.8 only works downward in the y. Gravity's pull left and right is 0. Finally, the phrase horizontal. If something's going horizontal, it means it's only going in the x. So if something's only moving horizontally, we're going to see that it really has no up and down motion at first. Why at first? Because gravity's going to start making a move. Number 4, the one idea we learned so far that does not depend on which way you're going is time. So time, it's in the air downward, and time it's in the air forward is always the same. And 5, since we have 2 directions, x and y, we're going to do our kinematic equations twice, once for the x and once for the y. So it's kind of like 2 problems in once. So write down the problem on the left. Make a little page, probably like about maybe half your notebook tall for this one. A pelican flies a horizontal path and drops a fish from a height of 20 meters. The fish ends 8 meters horizontally forward before it hits the nest. How fast was the pelican going? The first thing I always like to do, as you can see right here, is sketch a little picture out. So at this point right here, the pelican's going horizontal, is 20 meters above the ground, and then the fish goes boop and hits 8 meters away. The first thing I want you to do is to make 2 separate number lines. Look at these 2. From the up and down viewpoint of the fish, it starts off high, ends down low. I don't care about left and right for the y, because x and y are independent. From the x, or forward point of view, it starts off in the mouth and ends up forward in the nest. So, I'm going to now make these pictures a lot more in depth. Look at my y. In the start point, it's 20 meters up. And at the end point, it has a height of 0. It went down 20 meters. During that entire time, gravity's pulling it down. And most importantly, at the start point, it's only moving horizontal. And if it's moving horizontal, it's not moving downward. So I'm going to keep a note there. From the left and right point of view, it starts off with velocity because it's moving horizontally, but it's starting off no meters in front. The entire time it's going forward, gravity has no effect on its forward motion. And at the end, it ends 8 meters forward. Step 1, write down the things we know about x and y. Well, we have 2 distances. Those displacements we can put in. Notice why this is negative. It ended up below where it started. Below where it started is a negative y. If somehow this read a pelican throws up a fish, then this would be a different value, depending on when you're looking at it. The second step, write an acceleration. Gravity's pull is in the y, negative 9.8. Gravity has no pull in the x, 0. Step 3, the phrase horizontal. Says it has no velocity downward at the start point. It's 0. The initial velocity is 0 for y. The initial velocity is entirely in the x, and that's our goal. Once more, since it's only moving forward at first, it has a horizontal path. The first moment it lets go, it's moving only horizontally. Gravity is pulling on it, but has not had a chance to actually make a move. The moment after it let go, it will start getting to be a little bit quicker and quicker and keep speeding up in the downward direction. It will not speed up in the forward direction. That's why this is 0. Step 4, the time's the same for both. With this setup, we can now do the math. But here's the thing. The thing that's difficult for you is going to get to this point. I need you to constantly make these pictures and pick out the key words and phrases in here. So you better go back and underline the key points and link them in. Strategy 5, execute and solve. We only need one more piece of information in X to get our goal. We have 3 things in Y, only 2 in X. So let's use the Y information to get the time for the Y. And that downward time it takes to hit will be the same time as the forward time. And therefore, we can then use that forward time and solve what we need, which is the forward velocity. So here's my work for solving for time and Y. Based on my table, I went back to my formula sheet and I picked out this equation. I plugged in my numbers. Again, negative because it ended up below where it started for D. Initial velocity is 0. Gravity is negative 9.8. I ended up with negative 20 equals negative 4.9 t squared. I divided both sides by negative 4.9 to get t squared all alone. Notice the negatives drop. If you ever end up with a square root of a negative, you probably messed up your displacement sign. And I solved 2.02 seconds it took for the thing to drop down. And that's the same time as it took to go forward. Based on the table again, I used the same equation. But this time I looked at the X table. I plugged in numbers. Notice the acceleration in X is 0, so all this is going to go to 0. And I solved initial velocity and I got 3.95 meters per second, positive because forward. And we just solved for what we needed. Once more, copy this problem down, restart when you're ready. Okay, so in this time I give you the horizontal velocity. You're trying to find how far from the base. Can you please now draw a picture? Should look like mine. At this starting dot, it is moving horizontally. 1.5 meters above the ground. We're trying to find how far. Please make your number lines. Check out how yours compare to mine. 1.5 meters tall, horizontal velocity. The only thing that's kind of different compared to last time is that I don't know this meters at the end, but I know the velocity in the beginning. And since the acceleration is 0, that's the velocity for the entire point. I'm sorry, for the entire number line. Step 1, give me your X, Y information you know. Negative 1.5 because it ends below, unknown. Step 2, write the acceleration. Step 3, can you write in anything else you know if it's horizontal? Step 4, your time. Now I would like you to please, right now, figure out what you're going to do in order to solve for this displacement. If you want to execute it and check with my work, that's perfectly fine. If you want to wait and see how I do it, that's cool too. It's about you learning. Again, in this case, not always, just in this case we just saw again, we're going to use the time in Y to find the distance in X. We're going to get time with Y, we're going to use it to solve distance in X. Here's my work. You can see how I got 0.553 for time. Negative 1.5 divided by negative 4.9. And in the X direction, I use the same equation again because I have the same tables as last time. And you're going to see how I get 1.1 meters. Ladies and gentlemen, it's been a pleasure. If you have questions on this, write them down and address me in class. I really want to hear them from you. This is something you'll be doing a lot, and the more we practice, the better off we'll be. Thank you. Have a great day.